Okay, so in the fifth unit of Myers Psychology for AP textbook, we're going to be going over states of consciousness. Consciousness itself is defined as our awareness of ourselves and our environment. And coming off of a chapter that's focusing on behavioralism, the learning chapter, consciousness certainly is very, very different from the types of things that behaviorists would be studying. For a time, psychology seemed to ignore consciousness. Cognitive psych was really the entrance into psychology with William James and Wilhelm Wundt, and they really looked at our cognitive processes, and consciousness falls under that umbrella. And then it went out of vogue a little bit, especially with behavioral science. But starting in sort of the 1960s, 1970s, consciousness very much came back to the forefront. And there are all sorts of different states of consciousness, some of which are intentionally induced, sort of by choice, some of which our body creates, some of which are more psychologically induced. And there's just some examples listed here: daydreaming, dreaming, hallucinations, sensory deprivation, hypnosis, meditation. And so you can see how states of consciousness involve differing levels of awareness of ourselves, our environment. But one of the biggest areas of study for a psychologist who's looking into consciousness is going to be looking at sleep and dreams. So that's where we're going to start. In order to start any discussion of sleeping, we first need to understand the ebb and flow that our body goes through over the course of a night. And one way that we do that is we engage in sleep studies. And so when someone goes in for a sleep study, their brainwave patterns are recorded. And you guys should know at this point what technique is used to record those brainwave patterns. In that brain technique is going to be an EEG, or an electroencephalogram. You can see here just an image of the type of cap you would wear. And so by engaging in sleep studies, psychologists have determined that your brain actually emits different types of waves or operates according to different patterns of activity, and not just during the course of your sleep cycles, but then over the course of an entire day. Not just our brain, but our body goes through different waves of activity. And so another really important concept for the study of sleep is going to be the concept of circadian rhythms, which you guys have probably learned as being defined as, your biological clock. And it refers to the fact that we have cycles, certainly, of sleep and wakefulness. I think that's what we usually think of when we think of circadian rhythms. But then there are a couple of other areas where our body is going to cycle through things on a 24-hour cycle. Now, some of that is potentially artificially impacted by our modern lifestyle, by artificial light. But in general, our body's natural clock that it wants to set to is a 24-hour clock. And whilst most of us think of circadian rhythms as referring to how we tend to get, sleepy later in the day, and then we wake up in the morning, there are also temperature changes that happen over a 24-hour cycle. Your body temperature is going to rise in the early morning. It's going to peak during the day. It's going to dip during the early afternoon, right around when a lot of cultures take siestas. Those seem to match up with your body's circadian rhythms, and then it drops again as we go to sleep. Your body cools down when you're sleeping, and so that's one of the things that goes hand in hand with the fact that you start to get sleepier. Now, the way that we start to feel tired and the neurological reason why we get sleepy as it gets later in the day has everything to do with light intake and how our body interprets that light. As light starts to wane during the course of the day, information is sent to a part of your brain known as the suprachiasmatic nucleus, and the SCN are located in your hypothalamus, and what they're going to do is is at night, the SCN is actually going to secrete, or is going to talk to your pineal gland, and your pineal gland is going to secrete melatonin. But in the morning, you have retinal proteins, which are going to register that there's a lot of light streaming in. Those retinal proteins are going to be activated. They're going to go communicate to the SCN, which is going to tell your pineal gland to stop producing melatonin, which makes people sleepy. And so you can see why artificial light especially can have an impact on the melatonin production within your brain. Artificial light is going to be a false message to your brain that it's still daytime. And so your brain will hold off on producing or releasing melatonin because it thinks that you still are supposed to be awake. And that's why when put in artificial light environments, humans as well as animals will push their circadian rhythms to more of a 25-hour cycle as opposed to a 24. Now, what's kind of interesting is how circadian rhythms match up with our ability to think and cognitively process. And our thinking tends to be sharpest when our circadian rhythm arousal is highest. And what's really cool is that different people actually have different times when they're most active and when they're sharpest cognitively. The terminology sometimes is used in psychological literature to talk about people being either owls or larks. Owls you think of as more night owls, and larks are more of a morning bird. And what we see is that younger individuals, especially adolescents, are more on the night owl side of things. And as you get older, as you start to hit your 20s, going into your 30s, you start to see a shift of people who go from being these more night owls, where their really prime time is later in the evening, and they shift to being more morning people. And right in that morning time period, as their body temperature is rising up until mid-afternoon, they tend to be at their sharpest. And so the performance for owls is going to improve as the day goes on, as opposed to larks, where, like I said, the morning is their time, and then their performance is going to start to decrease. And you guys might have encountered some of this discussion before, whether or not you heard the phrase owl or lark, when school start times are discussed. For example, our high school starts at 7:40 in the morning, which is real early, and it probably feels much earlier for our students than it does for our teachers, because an adolescent circadian rhythm is more on the owl side of things. And so adolescents oftentimes don't start feeling sleepy until 10, 11 o'clock at night, and they want to sleep until around 8 or 9. And it's not because they're lazy, it's just because their circadian rhythms are set that way. And so some districts are now trying to match up their school start times with what the science says fits with how teenagers or adolescents will perform best. When districts shift their school start times to a little bit later, they tend to see improvement in test scores, as well as decrease in traffic accidents. And so that's something that a lot of schools are thinking about now to match up start times with what the science says.